T-minus 15 seconds. Guidance is internal. 12, 11, 10, 9. Ignition sequence start. 6.
Apollo 11 begins its journey to the moon. Mankind's dream of reaching Earth's satellite is reality.
We copy you down, Eagle. Tranquility Base here. The Eagle has landed. It's one small step for man, one giant leap for mankind.
The entire planet watches this historic event live via the world's first global satellite network. This network is owned and operated by the nations of the world as members of the International Telecommunications Satellite Organization, Intelsat. In 1992, Intelsat and NASA will collaborate on a unique mission, retrieval and reboost of one of the world's largest communications satellites. This mission will enhance knowledge of space operations and increase Intelsat's ability to provide telephone, facsimile, data, and broadcasting distribution services to virtually every country on this planet. March 14th, 1990. Intelsat 6 Flight 3 is launched. Had the launch been successful, the satellite would have separated from the second stage of its launch vehicle, ready for firing of the rocket motor that would put it into transfer position to achieve geostationary orbit.
This is Titan Control. We have to make a change in our previous announcement. Mission Director Vic Whitehead just reports that the data that they received here at the control center was not correct. We did not receive confirmation. Repeat, we have not received confirmation of separation at this time.
But the launch vehicle's second stage fails to separate from the satellite and its rocket booster. The satellite, still mated to the launch vehicle, is in an unstable orbit, 100 miles above the Earth. This orbit has a period of 89 minutes. Intelsat engineers begin an intense and dramatic effort to save the satellite from re-entry burnup, only hours away.
The commanding here.
Got it. Just keep going.
Let's keep going, Harry.
Don't wait for confirmation.
Don't wait. Just keep going.
We verify hardware window reset and disable.
It's a serial number.
Okay, that got in. Okay, we got a load status. We're going. Keep going.
We are.
Yeah, that got in.
Keep going.
Keep going. 100 seconds. That's the right command. 100 seconds got in.
Go.
The errant satellite, orbiting the Earth, provides only 7 minutes at best of telemetry and command opportunity for each Intelsat tracking station.
Any updates on Millstone?
The only thing they've said is they are tracking something now which is cylindrically shaped 5 meters by 3.8 meters, which must be us.
And separating from the other then?
We didn't talk about separating, just said this is what they're tracking now, is our bird. So.
And any decay of that?
Nothing was said about that at all.
Okay.
Yes.
When you talk to Mix, maybe you can ask about the other object where?
Our second stage compadre.
Yeah.
There's the second stage in PKM. If it's separating...
It is especially difficult for the Intelsat tracking stations to communicate with the satellite because they are not designed to track low Earth orbit spacecraft. By ground command, Intelsat was able to separate the satellite from the rocket motor and launch vehicle second stage. This maneuver saves Intelsat 6F3 from re-entry burnup, but leaves it stranded in an unusable low Earth orbit.
Verified. Executed. Verified. Entering command. 00012034. Transmitting. Verifying 00012034. Executing. Verified. Do you wish me to clear?
Yes, clear.
Clear transmitted and verified.
Nice job, guys. Nice job.
After 36 hours of intense commanding activity, a crucial reorientation of the spacecraft was performed, and the orbit was raised to 300 miles. After several months of engineering consideration, Intelsat contracts with NASA to reboost the stranded satellite. Endeavour, NASA's newest space shuttle, is chosen to carry a replacement rocket motor into space to reboost Intelsat 6F3 to geostationary transfer orbit. Hughes builds a special cradle to carry the rocket motor safely in the shuttle bay. A veteran astronaut team undergoes special training for the intricate maneuvers required for capture and attachment of the replacement rocket motor. At Johnson Space Center, astronauts simulate the tasks they will perform at zero gravity. At Ariane space facilities in Kourou, French Guiana, they test the tools and equipment they will use in space on another Intelsat 6 satellite. The Reboost mission is a unique operation and the most complex satellite retrieval involving the first dual-active in-orbit rendezvous. Intelsat engineers prepare the complex communications network necessary to support the joint mission. Intelsat Mission Control in Washington, D.C. is the focal point of Intelsat's command network, comprised of stations located in Tangua, Brazil, Gandoul, Senegal, Jadalahur, Indonesia, Perth, Australia, and Pamalu, Hawaii. Intelsat tracking, telemetry, and command stations will keep Intelsat Mission Control in contact with Intelsat 6F3 as it circles the Earth in a 300-mile orbit. After Reboost, TT&C stations in Beijing, China, Clarksburg, Maryland, Reisting, Germany, and Fucino, Italy will come online for antenna deployment and in-orbit testing. Telemetry data received via this network will tell Intelsat Mission Control the state of the satellite's health and its position relative to the shuttle. Intelsat 6F3 should be in a control box 46 hours after liftoff. The control box is like a moving window in space, a very large window that extends over 6 degrees of arc in a 200-mile circular orbit. NASA will define the parameters of the control box a few hours after liftoff. Engineers at Intelsat Mission Control will begin sending a complex series of commands to 6F3, gradually lowering the satellite's orbit into the control box. NASA astronauts will capture Intelsat 6F3 and move it into the shuttle bay. After a camera survey of the satellite to confirm that the spacecraft is fit to continue with the mission, the astronauts will attach the replacement rocket motor and release the spacecraft. Once the shuttle has moved a safe distance away, Intelsat Mission Control will send commands to fire the rocket motor. The spacecraft will zoom into a supersynchronous orbit, reaching a fourth of the distance to the moon. This maneuver is designed to conserve the satellite's fuel and extend its service lifetime. Once in supersynchronous orbit, Intelsat Mission Control will transmit a series of commands to the satellite to bring the satellite gradually into geostationary orbit. Intelsat Mission Control will send more than 250,000 computer commands to deploy the satellite's solar drum, and thousands more commands to deploy its communications antennas. Before going into service, the satellite will undergo extensive testing to ensure that all of its systems are operating properly. Intelsat 6F3 will provide communication service in the Atlantic Ocean region into the 21st century. Through the joint efforts of an expert team of international scientists and engineers from Intelsat, NASA, and Hughes, the spacecraft will join 17 other Intelsat satellites in the global network that serves the world, providing international and domestic telephone service to billions of people, business communications to major international corporations, and live television coverage of major world news and sporting events, such as the 1992 Winter and Summer Olympic Games. Instantaneous global communications, access to virtually any point on Earth, no matter how remote, can be accomplished in seconds via the Intelsat Global Satellite System. This rendezvous in space will help Intelsat in its mission of providing high-quality, reliable communication services throughout the entire world.